Welcome back. Let us see question number 41. An organization plans to migrate its deployment environment from on-premise cluster to a runtime fabric cluster. Okay. It also has a requirement to enable Mule applications deployed to Mule runtime instance to store and share data ap- across application replicas and restarts. How can these requirements be met? Okay, to store data and share data across applications, we use object store, right? So the option is this one, configure persistence gateway in RTF. Uh, uh, yeah. Configure, what is this option? Configure any points object store v2 to share data between replicas. No, object store v2 is not applicable in RTF. It is applicable only in Cloud Hub. Configure persistence gateway in any of the servers using Mule object store. No. So this is the option. I have Googled and I'll point you to the documentation. Anypoint Runtime Fabric provides persistence gateway, which enables Mule applications deployed to Mule runtime instances to store and share data application replicas and restarts. Exactly. This is the statement, right? So the option is configure persistence gateway at RTF. Okay. Next question. A Mule application is built to support local transaction for a series of operations on single database. The Mule application has scatter gather that participates in local transaction. Okay. What is the behavior of scatter gather when running this local transaction? Actually, after seeing this question, I tested a simple application using scatter gather and transactions, and I saw that execution of each route within scatter gather occurs sequentially. Separate threads will not be used if you are using scatter gather in a transaction. Okay. Any error that occurs inside scatter gather will result in rollback of database operations. So I have tested a scenario for this and I know that this is the answer. Okay. So this is the correct answer. Remember that scatter gather will not use multiple threads for each route if you are running in a transaction. That is the concept. Okay, so next. An organization is building out a test suite for their application using MUnit. Okay. The integration architect has recommended to use test recorder in Studio to record the processing flows and then configure unit tests based on captured events. What are two considerations that must be kept in mind while using test recorder? Actually, have I'll point you to documentation. When using test recorder in Studio, there are some limitations. One of the limitation is you cannot create tests for flows with mule errors raised inside the flow, right? And I see one of the option, this one, test for flows cannot be created with mule errors raised inside flow or already existing in incoming event. And there is one more, a recorded flow execution ends successfully, but the result does not reach its destination because the application is killed. This is the another option, right? So here they asked for two considerations that must be kept. These are my answers. So again, it is difficult to remember all this. So I strongly recommend you to go through the limitations about test recorder, because in certification exam there will be questions regarding test recorder. So just try to remember this whatever has been mentioned, right? And for this particular question, my answers are these ones. Okay, next. A Mule application must periodically process a large data set, which varies from 6 GB to 8 GB from backend database, and write transformed data to an FTPS server using a properly configured batch job scope. Okay, so it is reading from backend database and writing to FTPS server. The performance requirements of the applications are approved to run on Cloud Hub 0.2 vCore with 8 GB storage capacity, and concurrency requirements are met. How can high rate of records be effectively managed in this application? So you are getting huge records. So use storing with file store repeatable strategy for reading records from database, and batch aggregator with optimal size. See, the thing is, maybe whenever we are writing such a flow, I will just design a flow what it looks like. Uh, Maybe they are reading rows from database. Maybe let's assume that the flow has select query, which is actually fetching based on a scheduler. Maybe, right? This database query will give huge number of records. So what we need to do is we need to enable streaming strategies. Repeatable file store streaming strategy we have to use. That is one thing. And as there are a lot of records, maybe after database we are using a transformer, and the question says they are using batch job. Now, while executing in batch job, we can use a batch aggregator. Inside batch aggregator, we can write to the file FTPS server they are using. So maybe they are using, right. So here configuring a streaming option will be good because the file supports streaming. As in when the data comes, the data will be streamed. So maybe the best approach in this is to enable streaming for database, repeatable file store stream. And here don't give a fixed aggregator size. Instead, streaming the records will be the best option in aggregator. So what the first option saying, use streaming with file store repeatable strategy. That is correct. For reading records from database. That is correct. And batch aggregator with optimal size. Okay, maybe this may not be more effective. So this is the second option. Use streaming with in-memory repeatable. Okay. As the dataset is so huge, using streaming with in-memory repeatable will not work. What is third option? Use streaming with file store repeatable strategy for reading records from database, and batch aggregator streaming to write. This is my option. Okay. So I don't even go through the last option. This is my option. Next. Okay. Next question 45. One of the backend systems invoked by API implementation enforces rate limiting on number of requests a particular client can take. Okay. So here they have given a diagram. I am writing a Mule API implementation and the backend system has some rate limiting applied. Okay. Both the backend system and API implementations are deployed to several non-production environments, including staging environment and also to production environment. Okay. The rate limiting of backend system applies to all non-production environments. The production environment of the backend system does not have any rate limiting. What is the most effective approach to conduct performance tests of the API implementation in non-production staging environments? So in non-production environments, there is rate limiting for the backend system applied. In production environment, they don't have rate limiting. So how can we conduct performance tests? See, whenever we are conducting any performance tests, uh, we should have same environments, same restrictions. But here, the production environment does not have any rate limiting applied. But rate limiting is applied in non-production environments. So you have to conduct performance testing of API implementation. So what is the approach? So I've seen all this. Among this, I will discuss this option. Creating a mocking service that replicates backend systems production performance. So backend system, we have to create a mocking service which replicates the backend system's production performance characteristics. Then configure API implementation to use mocking service and conduct the performance tests. So I feel this is the correct option. If I see the next option, conduct scaled down performance test in staging environment against rate limited backend system, then upscale the performance results. No, this is not at all correct. What this next option says, use MUnit to simulate standard responses from backend system. MUnit to simulate standard responses. No. Then conduct performance test to identify bottlenecks. No, this is not at all correct. Include logic within the API implementation that bypasses the invocation of backend system in staging environment and invoke a mocking service that replicates the typical backend system responses, then conduct performance tests. Okay, it's the mocking service is just replicating the backend responses but not the performance. Here this option says create a mocking service that replicates backend systems production performance characteristics. The first option does not say it uh, it replicates the performance characteristics. So I feel that option C, this option, whatever I selected, is most appropriate. Okay, next question. An insurance company is implementing a new Mule application that supports critical functions driven by REST API. Okay, claim payment rules engine hosted on Oracle ERP. As designed, a new Mule application requires many data transformation operations as it performs batch processing logic. The company wants to leverage and reuse many of its existing Java capabilities as possible. What approach should be considered when implementing data mapping and transformations between Mule and ERP in new Mule application? So there are some transformations already written in Java code. So if you want to leverage them, as the question says, the company wants to leverage and reuse as many of its existing Java capabilities. If you want to call Java code for transformations, yes, you can transform by calling any suitable Java class from DataWeave. It is possible. Other options says create new metadata RAML classes from Mule. How to create RAML classes from appropriate Java objects? This is not all possible. Invoke any of the appropriate Java methods directly. Okay. Create metadata RAML classes. What is this RAML classes? I don't know this option. We cannot create classes from RAML. There is no such tool. And using accessibility transformations. No, this is not correct. So the first option is the most appropriate one. Okay. So we'll see next questions in next video. See you.